Hello, my name is René. I'm a lead developer at Kaleido AI, a visual AI company based in Vienna. We are part of the Canva family. And our mission statement at Kaleido is to make visual AI simple and easy to use for everybody. We currently have 3 services: Remove BG for removing backgrounds from images, Unscreen, which does the same for videos, and our newest product called Designify, which takes this whole thing to the next level, where you can automate design creation based on multiple AIs. Today, I would like to talk about service objects and how they can help us structure and improve our business logic in code. The starting point will be MVC, Model View Controller. It's the standard architecture for a lot of frameworks, including Rails, which we heavily use at Kaleido. The model that holds the data and the logic. The view represents how to display this data. And the controller that usually does the work and points then to a view to render. And that works really well for small apps, but it gets increasingly complicated and difficult as the application grows, because one of 3 things is going to happen. The first one is fat models that violate the single responsibility principle. We end up putting things into the model that don't belong there. We put other models in there. We put services in there. That's called fat models. Then controllers that do way more things than they are supposed to do. They should just take an HTTP request, do some work, or let somebody else do some work and produce an HTTP response. And the third thing that happens is logic in views. And this one usually comes up first. And that's why we introduce often another layer called the view models. And that only deal with the logic that deals with the presentation of the data that the model holds. For example, you can think of a Unix timestamp that we need to convert to a human readable date. And this view model is a type of service object. But still, none of these layers give us a good answer to where do I put business logic that spans over multiple domain objects. And the answer to that is service objects. There are quite a few: adapter, command, decorator, query object, view model, presenter, form object, basically an endless list. And today we are mainly talking about the command pattern. So what is the command pattern? It's described as a command represents and executes a business process specific to your application. Sounds cool, but how does it look? So here we have the basic example of a service object. It consists of 3 parts: the initializer or the constructor, where we can pass in our parameters or objects that the service object is going to work on. 1 public method called call, or you can use execute or process or whatever. And 1 or more private methods that actually do the work. And as an example, I would like to refactor a fictional method where a user can scribe to a plan on a website, like we all know, and you can do that on Remove BG as well. And we're going to do this with code examples to help illustrate where we are and what we are going to do to make it better, and what actually makes the new implementation better. And the code I'm going to use is a mix of Ruby and pseudocode, because Ruby is my weapon of choice, and pseudocode starts to make it a little bit more readable. Okay, so where are we now? Here is how our current subscribe method might look like. So this is a controller method. We come in with a request, and first thing, we load a plan. Then we do some basic checks if the plan is available, or if the user has already subscribed to the plan. So some very basic checks. Then we actually have some more complicated checks that we might have already moved out of the controller if a user can subscribe to that plan. And only if this check then completes, we actually subscribe the user to the plan. We get a payment processor because we support different payment processors for different users, credit card and Stripe in Europe, and the Chinese payment methods for Chinese customers and so on. And of course that can fail. So we need to catch an exception and then return an error. If everything is successful, we have subscribed, we have the payment, we want to send some notifications. And finally, at line 29, we can render the success. So this is how our starting point, our fictional subscribe method looks. And there are a bunch of problems with that. There are multiple ways to deal with errors. We have some early returns. We have some longer if statements. We have one on line 12 that spans all the way to the end. So it doesn't follow a simple logic. So we have these long jumps. We have multiple exit points out of the controller. So we exit at the beginning, we exit in the middle, we exit at the end. And it was a little bit hard to see, but we are already 5 nesting levels deep. So nesting levels are also a problem with this implementation. And yeah, we are going to refactor this. And therefore we should set some goals for the refactor. We want to improve the readability. We want to improve the structure. We want to make the code easier to understand and follow. And of course, easier to test, because the current implementation always requires a request, but we will get to that in the end. And so in our ideal world, this is how the controller method would look like. We get a plan, we get a payment processor, we call one service object, we pass in the plan, the user, and the payment processor, and then we render whatever that command returns. So it's very clear what is going to happen, and we only have 1 exit points, no nesting levels. Seems good, but there are quite a few steps that we need to make to get there. And the first thing here is a response object, and we are going to, all of our service objects, no matter what they do, they will return a service response at the end. The implementation details don't matter too much. There's only 2 things that we need to know about currently. You can add errors to the service object, and we consider a service call failed if it has at least 1 error. Okay. And here's how our actual service object looks like. So we have an initializer where we pass in, like we saw before, the plan, the user, and the payment processor. And this one public call method that the outside world uses to communicate with our service object. And this service object makes it very clear what it's going to do. It's going to validate data, it's going to subscribe a user, it's going to notify someone, and it returns a result. So this is the only public interface, and that brings us to the private interface. And first we start here with the validate method. And the first thing we do here is we return early if we already have an error. So we return unless the current result is still considered a success. So if any method before has added an error, we don't care about it anymore. You don't need to do that, but we do that here. And then we check again if the plan is available and if the plan can be subscribed to. And for each of those cases, if we have a problem, we add an error to that result object. And then we get to the subscribe method. And if we added an error in the validate function, we are not going to do anything. We are going just to return early. But if it's still considered a success, we are actually going to subscribe. Again, we subscribe in the database and we update the subscription for our payment processor. And then, of course, we still need to rescue the exception. But there is only one way now to add errors to the outside world. We just add a payment error based on that exception, like we did in the validate function before. So there is only one way to make the service object fail. And then the notify method, we again return early and then send some notifications if everything is still fine. So what about testing? How is this now better, apart from being more readable? This is the basis that we are going to use for all of our tests. We called it before each test. So we set up a user, we set up 2 plans, the old plan and the new plan, and we subscribe the user to the old plan. So he actually has something to change there. And here's how the test for a subscription with a payment error might look like in our original implementation without the service object. So we call the setup test method. And then, because the controller just instantiates a payment processor, we need to mock it. We need to allow it to be, we create an instance tuple here, or a spy, however you want to call it. And we need it to be able to be instantiated with new. And if we call update subscription on it, we want to return an error. And then, because we have a controller method that we want to test, we need to authenticate and log in a user. We need to visit the subscription path, like the interface, the actual interface. We need to select the new plan and we need to click on subscribe. And then we actually execute the controller method, and then we check if the result page has the content somewhere payment error. And yeah, there are quite a few problems with these kinds of tests. They always need a request. They always need authentication, so you always need to take care of that. They need a shadow browser, or like even with JavaScript support sometimes, depending on how you display that error, because it might be JavaScript with a toast somewhere and you need to support that. It's tightly coupled to the markup because we are clicking on a button that is called subscribe, which has nothing to do with our update function that we actually want to test. And it's hard to force errors because you need to always create instance tuples and spies and whatever. And they are slow because they go through the whole MVC stack all the time, even though they don't need to. And of course, like this whole login and clicking on stuff, this was just pseudocode. So you actually, it's more than one line. So I actually abbreviated some stuff here to make it easier. And yeah, and here's how our test might look with the service object. We could still do the instance tuple or the spy, but we can also just create a payment processor error that just inherits from payment processor and just raise the exception ourselves with whatever we want to do. So it's very easy and doesn't depend on the actual implementation of the payment processor. We set up the test. We call the service object with the new plan, the user, and our just created fake payment processor. And then the only thing we have to do is to assert that the result is a failure, because that's the only thing we care about. So that is quite easy compared and quite more readable. There are some rules to writing a service object. It only has one public method, the call. Everything else is private. You cannot instantiate anything inside there yourself, so everything has to happen with dependency injection. It deals with objects, so you don't pass in IDs of users in the database. It only operates on objects. You're not tied to your ORM mapper. They return something meaningful. True or false might be okay, but a result object with where you can actually get the errors and where they happened might be more useful. We handle the exceptions inside, so no exception handling on the controller. They do not store state. For obvious reason, this should be as functional as possible. And if possible, they should be idempotent, so you can run them multiple times without breaking it. So if the payments fails for whatever reason, I just be able to call the method again, and then it fails. It should not like leave it in a half-broken state. Yeah, and as with all rules, follow them long enough until you know how and when you can break them for your own good. That brings me to the end of my presentation. I have to say we are hiring. We are 50 people from 20 nationalities. We have more than 20 million monthly users, and we process more than 200 million images and videos per month. So if that sounds interesting to you, we are a fun bunch. Go to kaleido.ai/careers and see what jobs we currently offering. Thanks.